Hey everyone, welcome back to AP Precalc. This is lesson 2.7. Let's get right into it. All right, so here's the bell ringer for today. Pause the video if you haven't done this already because I'm about to go over the answer. So Mr. Herc believed a set of data displayed exponential growth. He used the data set to create an exponential regression model in Desmos. The residual plot for his model is shown above. Based on the residual plot alone, right, which of the following conclusions is correct? And so we want to see if the model was appropriate or not appropriate, and does it display a pattern? So here, right, for this residual plot, there really is no apparent pattern, so we can eliminate C and D. And then, because there's no pattern, that's a good thing, right? That means the exponential model was appropriate. So remember, no pattern equals a good thing in AP Precalc. So you do not want to see a pattern in the residual plots. You want them to be very random. And so A should be the correct answer there. All right, so now today we're going to be talking about composition of functions. You've probably seen this before, but just to introduce it again, just remember a function, right? You could either say y equals 2x or f of x equals 2x. And what it is these are the same thing, right? In this case, this is your input. So whatever you have inside the parentheses, you're going to plug in whenever you see x. And then f of x is your output, right? Your y value. For example, if you had the point 3, 6, what that would look like here is f of 3 for this function should equal 6. And so functions are very similar to a big machine, right? You plug in an input and it spits out an output. And so, for example 1, consider the function f of x equals 2x minus 3. Evaluate the following. So here we're plugging 5 into this function 2x minus 3. You're plugging 5 in wherever you see x. So this is 2 times 5 minus 3, which should just be 7 for the first one. So this should be 7 here. To find f of negative 1, you're now plugging negative 1 in for x, which should be negative 5 there. Now a, you have 2 times a minus 3. This just simplified is 2a minus 3. You can't really simplify that anymore. So that should be our answer there. And now f of x. We plug x in for x, which is 2x minus 3, which is just that original function, which, funny enough, is, right, f of x. What is f of x? F of x is 2x minus 3. It's what we just did there. So that should be example 1. All right, so let's try example 2. So what composite functions are is sometimes in math, we'll plug x into a function, and we won't be done just yet, right? Whatever answer you get, that's not going to be your final answer. Then maybe you have to plug that into another function, like another machine, and then whatever you get there might be our final answer, or you may need to keep doing it again. When we plug our output, what we get from one function into another one, that is what we call a composite function. And so let's try this. What is g of 3? Let's just plug 3 into this equation. So this is 3 times 3 plus 1, which is 10, right? So g of 3 equals 10. Now, what is g of f? Whoops, let me rewrite that a little bit better. What is now g of f of x? Well, this is going to be g, and then f of x is also just that. F of x is a function, but it's just that number 3. So this is the same thing as g of 3, which we're plugging into this function, which is just 3 times 3 plus 1, which we know is 9 plus 1, or 10. So here, g of f of x, this is like a composite function that is almost like the same as what we did here. So here, you almost did a composite function without even realizing it. And so hopefully that makes a little bit more sense. I feel like the more examples we do, the more you'll get used to what a composite function is. And so there are two different ways that we can write composite functions. You can either write it as f of g of x like that, or you could write it as f of g of x. Both of these are the same. Actually, on the AP exam, when they talk about composite functions, they will say both of these, so you don't have to memorize both. As long as I can recognize one, that's the biggest thing there. We read these as f of g of x is how we read those both of those composite functions there. And so, important note, when working with composite functions, we start on the inside. So if we were given f of g of x, we're going to plug x into g of x first, right? That's going to be our first step before anything else. And then we want to use our answer for whatever we get from g of x, and then just take that number and plug it into f of x. So let's try example 3. If f of x equals 2 times 3 to the power of x, and g of x equals 2x minus 5, evaluate the following expressions. Here we have f of g of 3. This is going to be f of, and then what is g of 3? This should be 2 times 3 minus 5, which is 6 minus 5, which is 1. So this is going to be f of 1, right? We almost can replace g of 3 with the number 1. And then f of 1 is 2 times 3 to the first, which should be 6. Now let's take a look at b. What is g of f of 2? We now first want to start on the inside and find f of 2 first here. So this is going to be 2 times 3 squared, which is 2 times 9, which is 18. And now we want to just find g of 18, which g of 18 should be equal to 2 times 18 minus 5, which is 36 minus 5, which is 31. So 31 should be our answer for part B. For part C, we have a composite function, but we're using the same one. So we want to find f of 0. So first, f of 0 is just 2 times 3 to the power of 0. Remember, anything to the power of 0 is just 1. So this should be 2. And then f of 2 is, we already kind of did this in part B, but f of 2 is 2 times 3 squared, which is 2 times 9, which is 18. So this should be equal to 18 as our answer there. It's a little messy. Let me rewrite that. 18 should be our answer for part C. All right, now example 4. Using f of x equals 2x plus 1 and g of x equals negative 3x, find general expressions. So here, notice we don't have any numbers to plug in, right? The inside is not g of like 5, it's just g of x. So we're going to plug in the entire function of g of x into wherever we see x in f of x. So this is typically 2x plus 1, but now it becomes 2 minus 3x plus 1. Simplifying this, you get negative 6x plus 1 as our answer there. So that's what this would be equal to. Now g of f of x, this is the other way around. So here we're taking f of x, the inside function, and plugging it in to g of x. So this should be g of 2x plus 1, which is negative 3, and then instead of x, it's going to be 2x plus 1, which is negative 6x minus 3, should be our answer there. And so notice f of g of x and g of f of x are typically not going to be the same unless they're inverse functions, which we'll learn about next class. More than likely, as long as they're different, like they're not going to be the same function. So just know that the order is important because you will more than likely get two different functions there. All right, now let's try example 5. Pause the video now, and I'll give you guys a few minutes for this because I'm about to go over the answers. So here we want to find k of h of 2. First, let's just find h of 2, which is using this equation here. So 2 times 2 minus 3, 4 minus 3 is 1. Now we just want to find k of 1, which is 1 squared plus 5, that's just 1 plus 5, which is 6. So 6 should be our answer for part A. Here, this is the same thing as h of m of negative 1, right? So I just like to write it like that because it's a little easier. So let's find m of negative 1 first. So this would be 3 times negative 1 plus 2, which is negative 3 plus 2, which is negative 1. So we just want to find h of negative 1 now. This should be 2 times negative 1 minus 3 is negative 2 minus 3, or negative 5. Should be our answer for part B. And then part C, what is k of p of x, or k of p of x? This is where we're going to take p of x, and we're going to plug it in for x in k. So this would typically be x squared plus 5, but instead of x, we're plugging root 3x plus 1 squared plus 5. Here, the square root and the square will actually cancel out, and we'll be left with 3x plus 1 plus 5, which we can simplify to 3x plus 6. So that should be our answer for part C there. Example number 6. We have a graph. We have the graph f of x. We have a table g of x. We have a piecewise function h of x. And we have k of x, which is a quadratic equation. And now we get to find all sorts of composite functions. So let's try these now. So f of g of 2, this should be f of, and then g of 2 from the table is 3. F of 3, right, when x equals 3, our f of x should be equal to 1 from that point there. So this should just be 1 for part A. Here you have h of f of 8, which is equal to h of, and then f of 8 should be negative 1. And then h of negative 1 is, remember, we have a piecewise function. So we got to look at the criteria for our piecewise function here, which is negative 1. So that's going to fall on this category. So we're going to plug negative 1 in there, which is negative 7 plus 3 times negative 1 absolute value, which is the absolute value of negative 7 minus 3, which is the absolute value of negative 10, which is equal to just positive 10 there. So that should be our answer for part B. Part C, this is g of h of 0. H of 0, it would fall under the top equation. So this would be absolute value negative 7 plus 3 times 0. Absolute value, which is just the absolute value of negative 7, which is 7. So this becomes g of 7, which is 4. So 4 should be our answer there. Now we have f of k of 2. This is going to be f of, and then k of 2 is plugging 2 into the equation. You get 2 minus 2, and that whole thing squared, which is 0 squared, which is nothing, minus 3 is negative 3. And then f of negative 3 is equal to 0 from the table, right there, that point. So 0 should be our answer for part D. Part E, g of h of 1. H of 1 should just be negative 4. So this is g of negative 4, and this should be equal to pi from the table. And then finally, f. Here, let's start from the inside out. So g of f of h of k of 3. Oh, wow. Let's first find k of 3. So k of 3, we plug it in here. 3 minus 2, that's 1 squared, which is still 1. Minus 3 is negative 2. So now we have g of f of h of negative 2. H of negative 2, we would plug negative 2 into the top function. So this is absolute value negative 7 plus 3 times negative 2. Absolute value negative 7 minus 6, which is negative 13, which is just 13 as our answer. So this would be g of f of 13. F of 13, there is no 13 on the graph, so this would be not possible. So that should be our answer for F. F is pretty tricky though. All right, example 7. On the free response of the AP exam, and you'll have one of these questions on my exam and the semester summative as well, you'll basically be given two functions. The first one will either be a table or a graph. Second one will be an equation. And you will be asked to find a composite function of this. They're not hard, so this is what I mean by they give you both definitions. Let h of x equal g of f of x. Find the value of h of 1. Here, you need to find it as a decimal approximation, and then you will need to show the work that leads to your answer. So very important here that you show work. So to find h of 1, this is the work that I would want to see, is equal to g of f of 1, which is equal to g of, and then f of 1 from the table is 1.75. Once you have that, then you would just plug this into the equation. So 1.75 cubed times negative 0.167, that minus 1.834 plus 1.75 squared. You should get your answer to be 0.333. You can give more decimal places, so it would be 484,375 after that, but that is all you need. You need 3 decimal places at least, and this would be enough work. I really just want to see that middle number somewhere in your answer to show that I know that you found the correct answer there. So when it says show your work, they're looking, I think, for that middle number and then your final answer as well. That's pretty much it. So if you have any questions, please come see me in office hours, and I will see you guys later. Thanks.